You've probably used an AI like ChatGPT and just had that moment of, wait, how did it do that? It can feel like pure magic, right? Turning a simple prompt into this incredibly detailed, coherent answer. Well, today, we're going to pull back the curtain and show you exactly how the trick works.
And you know, that's the most amazing part about all of this. You don't need a PhD in computer science to make this stuff work for you. This quote really hits the nail on the head. Everyone can write a prompt. We've all done it, right? Typed a question into that little box and watched the words just appear. It's become this totally universal thing.
But what is actually going on under the hood? What happens in that split second after you hit enter? How does a machine that fundamentally only understands ones and zeros manage to spit out poetry, or computer code, or a really compelling argument? That's the big mystery we're diving into. Okay, so here is the first and maybe the most important secret you need to understand. The AI isn't reading your sentence the way you and I are. It doesn't see words, it sees numbers. It translates everything you give it into a special kind of numerical code, and these codes are called tokens. Honestly, this is the bedrock. If you get this, everything else will start to click into place.
So what exactly is a token? The best analogy is to think of them as the atoms of language for an AI. You know how everything in the real world is made up of atoms? Well, for a large language model, every single piece of text, from a single letter to a whole library of books, is broken down into these fundamental numeric building blocks before it can even begin to think.
So, how are these tokens actually made? Well, a common way is this clever little algorithm called byte pair encoding. It's basically a super efficient compression trick. Imagine the AI looks at a giant chunk of the internet. It sees the letters T and H appearing next to each other all the time. So it says, hey, instead of wasting space on T and H separately, let's just create one new token, token number 587, that just means TH. It does this over and over, merging the most common pairs, building up a whole vocabulary of these efficient linguistic chunks.
Now, this is where it gets a little weird, and you can see that the AI's way of reading is not like ours at all. Take a look at these examples. The number 127. The model might see that as a single token. Easy. But 677. Nope, that might be two tokens, one for 6 and another for 77. The word egg gets split into E and GG. But put a space in front of it, and an egg becomes two totally different tokens. It's all based on raw statistics from the training data, not human logic, which really drives home that we're dealing with a fundamentally different way of processing language.
All right, so our text is now a sequence of numbers, of tokens. What does the model actually do with them? Well, this brings us to its one and only job. It's a prediction engine.
Believe it or not, this entire massively complex piece of technology boils down to one deceptively simple goal: predict the next token. That's it. That is the whole game. Whether it's writing a sonnet, debugging some code, or explaining quantum physics, at the most basic level, all it's ever doing is looking at the sequence of tokens it has so far and calculating the most probable next one.
The best way to think about it is like the autocomplete on your phone. You know, the one that tries to finish your sentences? Now, imagine that autocomplete was given a PhD, read the entire internet, and then was put on cosmic-level steroids. That's what we're talking about. It has learned the patterns of human language on such a massive scale that it's become unbelievably good at guessing what should come next.
Okay, I know what you're thinking, because this is the big question, isn't it? If it's just a superpowered game of guess the next word, how on earth can it do something that looks like complex reasoning? How can it solve a math problem it's never seen before?
And the answer is, we have to steer it. The magic isn't just in this incredibly powerful prediction engine, it's in how we, the users, learn to drive it with carefully designed prompts.
This is one of my favorite examples. It shows a technique called chain of thought prompting, and it is a total game changer. On the left, you ask a tricky logic puzzle, and wrong answer. But now look at the right. It's the exact same question, but we've added 5 magic words. Let's think step by step. And boom, it nails it. Why? Because we've forced the model to output its reasoning process as tokens. Each logical step it writes becomes part of the prompt for the next token it has to predict. We're essentially making it lay down a trail of breadcrumbs for itself to follow, guiding its own prediction process toward the correct answer.
So, getting a model to reason is already pretty mind-blowing. But the next frontier is about moving from just thinking in text to actually doing things in the real world. And this is where we get the really exciting concept of AI agents.
Think of a normal LLM as a brilliant brain in a jar. It knows a ton, but it can't interact with anything. An AI agent gives that brain a body. It connects the model's reasoning capabilities to a set of tools, like a web browser, a calculator, or the ability to call other software, giving it hands and feet to actually get things done.
And here's the key difference. A standard model's knowledge is frozen in time, based on when it was trained. An agent, on the other hand, can use a tool to go browse the web for up-to-the-minute information. A model just gives you one answer. An agent can handle a complex, back-and-forth task. The crucial leap is that agents have what's called a cognitive architecture, basically a framework for planning and acting.
So how does it decide what to do and when? It uses a reasoning framework, kind of like its own little internal operating system. And a really popular one right now is called React, which is a perfect name because it's all about combining the model's ability to reason with its new ability to act using tools.
This is basically a peek inside the agent's brain. It all happens in a loop. First, it has a thought, like, okay, to answer this, I'm going to need to find out who won the game last night. Then it chooses an action. I'll use the search tool. Then it creates the action input. Who won the Lakers game? The tool runs and gives back the result, which is the observation. Now, with that new info, the whole loop starts again until it has everything it needs to give you a final answer. It's this constant cycle of thought, action, observation, repeat.
All right, so let's wrap this all up. What are the key things to remember? First, AI models see the world in numeric tokens, not words. Second, their entire job deep down is just to predict the next token. Third, we can unlock their incredible reasoning abilities by steering that prediction process with smart prompting. And finally, agents are the next big leap, giving these reasoning engines tools to actually interact with the world.
And that kind of leaves us with a pretty big question to think about. We started this journey with what is essentially a fancy autocomplete, but we ended up with a system that can reason, act on a plan, and learn from the results. So you have to ask yourself, what happens next? What happens when the tools we give these agents become just as powerful and capable as our own? It's a huge thought, and it really shows you where all of this might be headed.